you so much for hanging out to the end of the day, coming along to this talk, and joining me here right now. As I was introduced, my name is Phil Nash. I'm a developer evangelist at a company called Twilio. Can I ask who here has actually heard of Twilio before? If you can put, so a few in the middle there. Cristiano's never heard of Twilio, that's cool. Didn't mention it in his talk at all. Cool, for those of you who don't know, Twilio is a cloud communications platform, which counts because we're on the cloud track right now. It's a platform for your applications to connect or communicate with your users via voice, video, or messaging using the tools, platforms, languages that you already use. I'm not really obviously talking about Twilio here today. It does show up in my demos, so keep an eye out for that. I wanted to give a quick warning, because of course we are here on the big data and cloud track, and this is not about big data at all. It's actually pretty much about small data, tiny amounts of data, just little bits all over the place. If you are interested in big data, I'm really sorry. This is not for you. It's about tiny little bits of data. And my clicker apparently has given up for the day. What is it doing? Sorry. Bear with me 1 second. Spoilers? Not really. I don't know what the... Fuck it. Okay. Oh, excuse me. Right. So, an empty database in every pocket. Let me forget about that part. Oh, thank you. What I'm trying to talk about here is web applications and the kind of problems and things that we have with web applications these days. Thank you so much for the swift technical support there. That's awesome. Problems with web applications these days. I think there are basically two. We have performance, and this matters in terms of rendering things to screen, but also getting. Well, it's all about rendering things to screen as quickly as possible in front of your users to give them a good experience. And secondly, and we've heard a couple of talks about this already today, it's kind of offline. Although I don't think offline is the problem, because that's just a state of being. It's more about maybe poor connectivity. Still just a state that your user's in, which we can't really control. And the final, so really what I mean is resiliency. For ability for a website or web application to work regardless of the situation it's in. And so if we can build fast websites that react quickly and are resilient in the face of dodgy network connections, then we get a great user experience. And that's what we're really all aiming for, I guess, so that people can use our applications and enjoy doing that and get the thing done that they wanted within that application. I didn't really have a photo for user experience that I could think of, so this is my dog after I tucked her in to bed one night. And I thought, if we can give our users of our applications the user experience of a dachshund tucked into bed, then we'll all be winning, I think, at that point. I also like to use it as an excuse to just show you pictures of my dog. Isn't she adorable? Cool. We've also heard today, if you were in the web and mobile track earlier, from Dan Applequist, that progressive web apps are part of this future that we are building better applications with, more resilient applications. We have things like service workers, which allow us to cache files offline, which really help out in that kind of thing. But what I've always found along the times of talking about service workers and progressive web apps is that the thing that gets forgotten is actually storing data. We're great at storing files and we're great at storing other things, but it's storing data tends to be the problem. And that is why I believe we all end up with an empty database in all of our pockets. And so what I mean by this is simply that we have all these web applications we're using on our mobile devices, and we have databases which are at our fingertips as developers that we're maybe not considering it all the time. So I want to talk a bit today about how we can use these databases, use these things that are available to us in order to improve user experiences and not get too scared by them either. Because as you probably know, there's a bunch of options that we have for storing data in the client side in a web browser. From almost the start of having web browsers, we started with cookies, which you can put data in. That's brilliant. We have cookies. Excellent. Really good for storing sessions, of course, and information like that. And not much information, of course, because it has a maximum size of, I think, 4K. And of course, you have to send cookies over on every HTTP request. So it's not the best use of our users' time to be sending and setting data within cookies. They're also not the easiest of things to work with. So then there's local storage API. Who's used the local storage API in browsers? Yeah, okay, a few people, and it's pretty good fun, right? It's really easy. You just set things, and then you can get them again, and that's it. It's a key value store that's really easy to use, and some things are awesome, so that's cool. Its only problem is that it's this. Well, firstly, it is a key value store. And so if you need to send anything that's more interesting than just a string, then you need to stringify that, presumably into JSON is the best way to do that, marshal that into data, and then parse it on the way out. So you're getting a performance hit in the first place simply by the fact that you have to stringify and parse data out of it. And secondly, it's synchronous. So if you are storing and moving a lot of data about, the writes actually can take quite a bit of time, and your application will be blocked from doing anything else if you are making writes to local storage. So that's a shame. And finally, local storage is not available in web workers or service workers. This is also a shame because, as I'm saying, this is really useful stuff for when we want to build applications that work offline. And if you can't use this within a service worker, it's not all that useful. So what are other options? WebSQL is a kind of popular one, right? SQL database in the browser, relational database that we're all kind of used to using on our servers. And the problem with WebSQL was that everybody did like it, and then all the browsers did implement it, except they all used SQLite as the underlying storage. That led to there being actually only really one implementation of the database in browsers, and the way the W3C works is very much that you need to have two competing implementations in order for it to become a standard. Therefore, since it was all one thing, WebSQL has been deprecated and won't be being used anymore. So it's gone. Nope. So we are left with, as mentioned at the start, we are left with IndexedDB. Now, who's played with IndexedDB before and used it? One. Cool. All right. Fun times with IndexedDB, Mike? Yeah, I know you like it. All right. But why actually, can anybody shout out kind of why you've used local storage, why not IndexedDB? Any? Browser support. Oh, okay. I mean, IndexedDB is actually supported in all major browsers, so that's cool. But that's a good one. Browser support. I imagine it's because, again, that local storage is a very simple API. It's really easy to understand straight away. Whereas I think IndexedDB has really just got itself a bad reputation over time. That it's hard to use, maybe that it's not supported, where it certainly is. And I want to change that, and that's the middle part of my talk here, is very much trying to change your mind and get you to try IndexedDB. I want to show you how fun it is to use and how we can make things better with it. So what is it to start with? Since we have, yes, one user of IndexedDB in here, let me tell you about how IndexedDB, or what it does. So it's an object store. It is not a key value store. You do use keys to save the data. However, you can put objects into it, JavaScript objects, and it deals with most of them. So you don't have to stringify dates and things like that. It will just take the date object that you pass in. So that's quite cool. It's also transactional. It very much IndexedDB allows the browser to kind of deal with its transactions and not the developer. This is very much, this points very much towards the next point, which is that it's an asynchronous database. So you basically queue up those transactions and allow the browser to deal with them and then call back to you when that is over, when the transaction is either complete or fails for some reason. Given that it's asynchronous, it's also then available in web workers and service workers, and any way you can use JavaScript in the front end. And finally, just in terms of security, it has the same origin policy, much like the rest of JavaScript. So you can only access data that's within an IndexedDB database or object store if you are on the same origin, the same port number, the same HTTP or HTTPS that you put that data in the first place. So I want to show this off. Just talking about it is not that much fun. So I have a little demo, which you can actually go and access yourself. I built a little chat application. This is using Twilio's programmable chat API to allow you to just send emojis as a chat. If you go to that URL, you can go and send emojis as part of this chat. That's philnash.ngrok.io. And if somebody does go and hit that, we should start to see emojis appear in the background. I'm going to leave that for just a second if anybody's trying to get the URL. And then I'm going to send an emoji myself. There we go, we got a cool sunglasses guy. All right, sweet. Yeah, good. Emojis for everyone. I'm gonna send my favorite one, which is more than one beer. It's just one more. There we go. Cool. So the problem with this chat right now is that when the page loads, it connects to the chat service, and then once it's connected to the chat service, it then loads the latest messages that have been sent. And so if I refresh that, we can see that it's taken a while. When the button at the bottom comes along, that's we're connected to the service, and then we get the messages. And this is not the best of experiences necessarily. When you load up a chat, you want to see the chat messages that have been sent almost immediately and start to interact with it. So we can do that, and that's what I want to build into this for today. So this is that application. As you can see, I've got this new chat, and we initialize it, and then when we get a message, we can add it to our list of messages, and that's how the chat works. Fairly simple. Well, I'm going to add some IndexedDB to this so that we can put all our messages into IndexedDB, and then as soon as the page loads, as soon as the JavaScript loads, we flush all those messages out onto the page, and then continue with the connection. So let's see how this works. I'm going to start up with just a database variable, which I will be adding to later, because we now need to open up a database and create it in the first place, because we have not created this yet. So we are going to create a request to do this. This is part of that transactional nature of an asynchronous nature of IndexedDB, and we're going to use open. I'm going to just call this message store, and then I give it a version 1. We haven't opened up a database yet. This request then receives those callbacks because this is being done asynchronously. So we might get an error. Let's hope not. But if we do, we'll just log it. Console.log error. Let's hope we don't get that. More importantly, we get the important on upgrade needed event that fires. And this is basically saying the database. This is the browser saying, I don't know what you're talking about. What database are you trying to open for me? What is happening here? And that point, we get an event which we can start to do stuff with. You'll see this come up quite a lot. So this is my upgrade database. I'm going to use it to upgrade and add our object store to it. And you'll see this a lot. We get events, and the events have a target, and the result of that target is the thing we're trying to do. So in this case, it is this new database. We'll see it later in messages and other things. And using this upgrade database, we're going to create an object store. This is, as it says on the tin, a store in which we can place objects. Brilliant. I'm going to call the object store just messages, and then we give it some options. In this case, I'm going to give it a key path. And this is telling IndexedDB which property in the objects that I'm placing into it should be used as the key. All things within Twilio have an ID which we call SID. You could name that key path something else, and you can use and you can pass an option there which auto increments the ID. In this case, we have an ID because the messages are being generated by an external service. And once we've done that, that's all we need for the database upgrade. And then we can, on success, and this is where my let DB earlier comes back in, because now we have access to the actual database, and so that DB object can be assigned, and will be assigned, as I said, with event.target.result. In this case, this is the fully upgraded database and ready for us to use. So that's cool. We've set up our database. We asked for an upgrade, and we said, all right, cool. We have an object store which we want to create with this key path. I'm going to do one other thing for now, which is when the chat object and the chat application receives a message, we're going to put that message into the database. Seems sensible. We're going to start with another request, a request to the database. And in this case, we're going to use a transaction. And the transaction, you can pass in an array of object stores that your database has to use. In this case, it is messages that we want. And then we need to tell it whether what method we're opening the database, opening this transaction in. So this is a read-write one. We're putting an object into the database in this. So we have a read-write transaction. That request, that's not a request then, is it? It's a transaction. What am I talking about? Huh. That transaction, of course, we can then get our object store. So even though I only have one object store, which is the messages object store, I still have to then ask for it from the transaction. If you loaded more than one store into the messages, you'd have to get hold of each of them by this way. And then finally, I do make my request because I want to take the object store and put a message into it. The messages come in via the event there, and an object store put message. I'm specifically using put here because the add is part of the API, and that will always kind of append to the database, putting a new thing in. Since I have these IDs as part of the message, and I can use put, which will either add a message to the database or update or replace the existing one based on the ID. So I can also, at this point, listen for success as well, but there's not much to say about it really because it's just going in the database. So I'm just like. Cool. So if I refresh the page now, let's go back to there. We're seeing some more emojis. It took a while for poop to arrive, but well done, whoever sent that one. So if I refresh that now, we're not actually still loading anything out of the database, but we are, as soon as the messages appear, going to put them into the database. So this is where we can take a look at DevTools. And as you can see, that's, I think, 30 yays there at the bottom, so that's cool. If we look on the Application tab in DevTools here, we can go and inspect our IndexedDB and our message store. And so we can actually see all our things within the database. And this is quite useful. Angel smiley and laughing smiley there, enjoying their time in IndexedDB. As I said, we have the SID, the ID, which is the key path and the key to all the things in this database. And then we have the object that's part of the database. As you can see, the actual key is still within the object as well. So this hasn't improved our experience yet. It's actually just taking time to add stuff to the database. Thank you, everyone. So in this case, what we need to do is on the load, and once we've got our database ready, load the messages into our page. So this is going to go back into that success event after the upgrade, after we've opened the database. And to do so, we're going to get a transaction. So what you can see at this point is that there's quite a lot of repetitiveness in IndexedDB. It's quite a low-level API, really, which includes a lot of repetition, and that's why it's maybe not that nice to use raw like I am doing right now. But that's why we have libraries and things for. Supposedly, the IndexedDB API was actually designed based on the XML HTTP request API, an API that I dislike, and no one's actually used since jQuery and Prototype and anything managed to overwrite it. So why they chose that as the basis of IndexedDB, who knows? But again, we'll use libraries to get around this. So I've opened my transaction. This is a read-only transaction in this case because I'm just going to read messages out of the database. And then I need to get hold of my object store from the transaction, which is messages, if I can spell that. And we'll open up a request. And so we're going to load all the messages out, but IndexedDB doesn't have just a kind of querying language as such, we actually have to open a cursor on the object store itself and run through the cursor. So I'm going to open this request using the object store object, and we're going to open a cursor. And so on the successful opening of that cursor, we are going to get an event. And in this case, event.target result will actually be our cursor object. So the cursor is actually just a pointer to a message within our an object within our object store, in this case a message. So if we have a cursor, if that actually does exist, then we're still running through the list of messages. And so I can, I will take my message list object, which is part of the application I wrote, and add message, the cursor's value, which is the object within the store. And then we need the next one, so I tell the cursor to continue. If we don't have a cursor at this point, then we are done. And so all we should do is use another just function I have on this page, render messages with the message list. And this is what we've put all the messages in the message list. We've got them all out of the database. Let's put them on the screen. So if that is all successful, then when I refresh this page, we should actually, and like I said before, you know that the chat service is connected when the little send button at the bottom has gone green. It's otherwise disabled. And what we should see is our messages appear on screen almost instantly. Almost instantly. Something didn't work. Cool. I have an error. That's cool. Transaction is not a function. All right, what have I done? Yeah, you're right. You're absolutely right. Transaction.object store. There we go. So this time, they've loaded almost instantly. The button is still gray, now it's green. And then we've added more messages to it. So with just a few lines of IndexedDB, and as I said, in this particular case, I'm writing it raw and we see all the repetition, we've instantly kind of sped up the way this application works for people. We could add more things to this, like when somebody, before the send button becomes live, we could still be writing messages. And even if somebody wants to send it at that point, we could store the message into an outbox within IndexedDB, and then as the chat service connects, flush them out into the thing as well. So, okay, whilst people are getting very excited about the emojis, I'm going to skip out of those now. You can continue to enjoy that until I close down the server later. So that is kind of how easy it is to get started with IndexedDB, and it may be a repetitive API, but I don't think it's a scary API at all. But there is more to it as well. Obviously, I can't show everything right there. I already ended up with one error in my code. It's called IndexedDB, so it has indexes. This is useful, of course, because this allows us to do more than just look at the messages in whatever order IndexedDB decides it's in. So if I was instead to have created my object store and added an index for date updated, then I can then query that index, in this case, in the same part that I did before for the cursor, using the index instead of just the store itself. And this will then sort all those messages into, in this particular case, date updated order, which probably is a sensible way of doing it. Secondly, we looked at upgrades in terms of creating the initial database and the onUpgrade needed event. But as your database starts to grow and you add more object stores to it, you need to do more upgrades. And so whilst we saw this in the first place, when you get to the next upgrade, you actually need to start thinking about this. Because if we try and create the object store on top of the existing one, then we're going to have a bad time. So you actually have to start looking at the versions. And you can kind of, this is a non-exclusive kind of if here. So if the old version is less than 1, then we've never seen, this is a browser that's never seen this database before, and so needs to create the original object store. And then if the old version is less than 2, then we can create a new object store. And so this allows a browser that's never seen it before to run through all of the things. And if we are a browser that has seen the messages object store, then our version will be 1. And so we just skip to the next one, skip to version 2, and create our new object store. There are, of course, bugs. This is software, after all, and this is something you probably want to be aware of, although it's going away as time progresses. The biggest and most awkward bug was due to Safari. Safari is an absolute nightmare when it comes to IndexedDB. And this is Safari 8 and below, or every implementation of IndexedDB in Safari 8 and below. And its problem was that if you had two different object stores, and you added an object to one of them which had an ID of whatever, you added a completely different object to the other object store that had the same ID as the original object, and that original object would get wiped out of its store, which is killer, right? That's horrible. So if you are going to work in Safari at all, you kind of need to, at least if you work in Safari and you have more than one object store and you need to support Safari 8 and below, then you need to manage your own IDs and ensure that they never match something in another store. That was Safari's biggest problem. It has gone away. Version 9 and version 10 do not have that problem, and I'm sure version 11 doesn't either, because why would you change it now? Exciting to hear new stuff coming in Safari 11, though, coming up. So that's the one thing to be aware of, is that nasty, nasty bug there. And as I said, it's this low-level API, so there are libraries to use for this, and this is where it gets more fun to write this stuff. These are just a few that I've tried and used and liked for various reasons. Let me tell you a little bit about them. The top one, IDB keyval, is written by Jake Archibald and is a 500-byte wrapper around IndexedDB that gives you a promise-based key value store like local storage. It doesn't deal with bugs like Safari has. It's a very lightweight wrapper. But it's quite useful for that kind of thing. If you only want to add a very small library, have an asynchronous key value store, and only support latest browsers. If you want a key value store that's asynchronous and works in IndexedDB that does in fact support all of the browsers and has all the kind of fixes for difference over browsers, then local forage is your friend. Local forage does. Yeah, asynchronous key value store. It's written by Mozilla. It's been around for ages. It is a lot bigger than IDB keyval, but it's very good. Then talking more about just IDB, there's another Jake Archibald one. IDB is a wrap around IndexedDB that turns the set of weird callbacks, the on success, the on error, the on upgrade needed, into a promise-based API. So if you like promises, you'll really like IDB. And indeed Dexy and PouchDB as well. Dexy, which I'll show a couple of examples for in a minute, is a more heavyweight wrapper than IDB, certainly. It includes quite an interesting querying language for IndexedDB, and is quite useful. And then PouchDB is an incredible project, in my opinion. It might not be what you need, but PouchDB implements the entire of the CouchDB API inside the browser on top of IndexedDB, and that includes its syncing protocol. So using PouchDB, you can effectively turn everybody's browser into an extension of a distributed network of CouchDB instances that store and sync data. Incredibly powerful. Might not be what you need, but check it out if it is. This is Dexy, though I quite like this one because it just makes things look a little nicer. So you don't have to deal with any upgrade needed events. In this case, you just say in the Dexy database in this message store, version 1 will have these stores, and these are the and the string there next to messages SID and date updated is the indexes. The first one in that is your key path, and then any subsequent ones will be created as indexes. Really quite nice. And then, as I said, it's got this kind of querying language. So one, it's promise-based, so you can open the database and go, all right, give me the messages where the SID is this, and that will return you that one message, of course. And you can do other kind of filtering and things like that, all based on this quite nice API over the top of IndexedDB. So that is kind of what I wanted to share with you this afternoon. We might have empty IndexedDBs because only one person, or two people, I guess, after myself, have used this in this room. But I think we can change that, and we can work towards a better place. Because I think IndexedDB, certainly in terms of even the simplest of thing that I managed to accomplish on stage with my chat application has enhanced the experience of that for users. And I think you can use it to enhance that by making things more performant and also, of course, more resilient. And that is it. So let's go out there and fill those databases. That is IndexedDB for you. Thank you very much for joining me this afternoon.
Questions?
Do we have any questions at all?
Considering the fact that only 2 people used it.
Well, you know, now they've seen it.
Yeah, it's working.
Yeah.
Great. Okay. No questions?
There are, of course, no questions. No, we do. We do have one.
We
yes,
have one.
Cool.
Okay. And
we have a microphone on its way as well. Right there.
Yay.
Nice. Very efficient service.
Okay.
It's not working, the mic. Try again.
Try one more.
Okay.
There we go.
It's working.
Is it working?
Yes.
Okay. Can you tell me a bit of the limitations of the IndexedDB query that you could do in other... Okay, it's not a key value store. It is, in fact, you can store multiple things. It's not just key value. How many things can you store? Does it have a limitation?
This kind of is different in different browsers, and it used to have more strong limitations, but I think these days that's much more lifted. I believe in Chrome, IndexedDB can take up to half the available space that Chrome has in the platform. Probably don't put that much information in there. I know it's the big data track, but no. You can actually put an awful lot of stuff in it. And it does, I think it's Safari, it will maybe still ask you for permission to put more than 5 or 10 meg into it, but most browsers have kind of lifted that restriction. And yes, you actually have an awful lot of space to work with. Of course, it depends on the size of the disk of the device and what the browser has available to it itself. But the limitations are, aside from asking for more than 5 meg on Safari, is it more than 5 or more than 10? 5 or 10 meg.
Also, any security concerns that we should be aware of for the... for storing sensitive information in the IndexedDB?
Yeah, so in terms of that, if you're open to an XSS attack that has access to the JavaScript, then that can go in and read everything out of a database and send it off to somebody else. But you have, your problem there is that it's an XSS attack, not that it's IndexedDB's fault. Similarly, I guess... yeah, no, that's kind of the problem, I guess. You will have to manage, if you are storing data for a person and they log out, for example, you want to be clearing the database at that point as well. Yeah, there is actually a very interesting proposal of a header that you can send on kind of a logout call, which I think it's being implemented in Chrome, will actually then clear all of the kind of data that your application has stored about a user out of any data store, including IndexedDB, and of course caches and things like that that you can deal with in Service Worker. I think this is a really interesting and important thing that I would like to see implemented around browsers, but you have to manage that pretty much yourself right now, and yeah, clear and data whenever you want to, whenever you need to, sorry.
Other questions? Phil, thank you so much for closing up the day, the event. It was a pleasure to have you here with us. A special thank you goes to Stefanini, the partner of this stage. A special thank you goes to all of you for creating such a challenging audience today for our speakers. I'd like to invite you on the main stage now, because we have many prizes for you to offer you, because you've been here with us. So don't go anywhere. Just take your stuff and go to the main stage. And I hope to see you later at the after party, Apollo 111, Apollo 111. We have good music, nice people, and great networking opportunities. There's anything else? And drinks as well, yes, and drinks as well. I think that's about it. Thank you once again. Yay.